everyone. So we'll be starting with the top interview 150 sheet from LeetCode. Since this is the first video, I'm going to take it slow, and this series will continue till we've completed a lot of questions from the sheet. We're going to start with remove duplicates from a sorted array question. This is an easy question, so if you have done this question, please feel free to move on to the other questions as well. And throughout this video I'll be thinking out loud, so if I make mistakes I'm going to try and debug that, and I'm also going to talk about how I came up to the final solution approach and why the other approaches didn't work. If you have any doubts regarding any steps that were done in the code, or if you have a better solution, please feel free to mention that in the comments. I would love to know about your solutions. I will be coding along you guys, so I might make any mistakes, so we're gonna try and debug this together. So remove duplicates from sorted array. You guys can find the link of this question in the description. Read the question. Till then you can pause this video, and I'm gonna give you like 5 minutes. So I'm assuming that you're back. Okay, so my first thought when I was solving this question initially was creating a new vector and storing the unique numbers in that vector. But that was when I did not know about the in place condition, right? So this is the first thought that pops into your mind when you think of such questions. So for example, I have a vector called v. I create a new vector called v, and my first thought is going to be, so I'm going to browse or move through the entire nums array that we have. I'm going to look at the first number. Obviously, first number is going to be unique because it's the first number in the series, right? So you're going to never have encountered a similar number because it is the first number. So directly we're going to add that number. So as we move on in this array, I'm going to keep checking, is my current number same as my previous number? If yes, I'm just going to skip that. If not, I'm going to add that. So this is my core concept of my solution. Originally, I was going to store these unique numbers in a vector, another vector, and as and when I complete this process of browsing through the entire nums array, so I have 0, 1, and then the next one comes. I look at my previous entry in my vector v, but it's the same, so I'm going to skip this. I'm going to go to the next one. I'm going to check the previous number in the vector, last inserted number basically. It's the same, so I go on and on and on. So I'll have 2 here, I'll have 3 here, and I'll have 4 here. So I get a set of numbers that are unique. Then I was thinking of transferring this vector v into nums and returning the size of nums, because now it basically contains the vector v, and that's what we want to return, right? Number of unique elements k. But the key word here is in place. So we need to remove the duplicates in place so that each unique element appears only once, whilst keeping the relative order the same. So the problem is, if we're creating a new vector, we're just consuming extra space, and extra space created is basically O of n, because we create an entire new vector. So that won't be optimal. But the core concept will be same in our solution as well. So the plan that we just constructed, all we have to do is use that plan but modify the existing nums array in such a way that the duplicates get eliminated. So the key observation here is to note that the duplicates, no matter where they are in the array, since the array is sorted, they are clubbed together. So they're present at the same place, right? So whilst I'm browsing nums array, whilst I'm moving through the nums array, why don't I make a list of unique numbers at the same time? So this is going to be our core concept. Okay, so like we discussed before, we're going to follow the same process, and we're going to construct a solution that modifies or transforms this array in place. So for this I'm going to need 2 pointers. I'm going to use the 2 pointers method, right? So I'm going to have, say, a pointer called I. This I will basically be responsible for traveling through the nums array. Okay, so this is going to help me with browsing. I'm going to have another pointer which I can call, say, insert at. Okay, so this pointer, as the name suggests, it is going to point at the index at which new unique elements need to be inserted at, right? So this will help me keep track of the index at which I'm going to be inserting new elements, right? Okay, so let's begin with coding the solution. Whilst coding, the first problem that I will encounter is, what if my array is empty, right? So this is an edge case, we have to treat it immediately. If nums dot empty, if nums is empty, is true, then we have to return 0. There cannot be any unique elements if the array is empty. Okay, another important observation is I have to initialize my pointers now, at least one of them, like insert at. So when I showed you this example, if you remember, I did say that 0 was the first element in our array and there's no element preceding 0. So, but obviously 0 has to be there in my final solution because I haven't encountered any number as of now to compare it with, right? So that is why we're going to initialize insert index pointer to 1. So insert at or insert index can be 1. So basically why this was done, because insertion now will start from index 1 because index 0 will but obviously be occupied by the first element with of the nums array, right? So similarly, the second part of this involves us starting browsing of the nums array from index 1 because we've already figured out what we need to do with the first element of the nums array. So we're going to loop through the nums array from index 1. So we're going to have a standard for loop, and in the for loop we're going to check if the current element is not equal to the previous, then it's unique and needs to be inserted in the answer. Okay, so answer vector here essentially refers to nums array itself or nums vector itself because we are not creating another vector, it's just for your understanding. So if nums of I is not equal to nums of I minus 1, we're comparing the current and the previous element, then we do nums of insert at, we're going to insert this element, the current element at insert at index, right? Okay, so this is done, but now we also need to update insert at pointer because a new element has been inserted at this index position. So insert at pointer should now be updated. That's what we're doing in the if condition. So now they're asking us return the number of unique elements k. Essentially that is basically insert at index. You see, because insert at pointer acts as both the pointer for the next available slot and a running counter of unique elements found. Since we had initially started the pointer at 1 and incremented it every time we found a new unique value, it correctly represents the total count of unique integers that the problem is asking us for. So if you notice, even in the code, insert at pointer is always one step ahead of the last unique element we placed. In order to make the reason simpler as to why we are returning insert at pointer location, notice that insert at pointer is always one step ahead of the last unique element we placed at any point in the code. Since arrays start at 0, this one step ahead value is exactly equal to the total count of elements. So when we are at the end of the entire process, when our nums array has been restructured, so let us say it has 4 elements. So insert at will be pointing at index 4 because even if it has 4 elements, if we take 0 indexing in mind, insert at will be pointing at index number 4. So when we are returning index at pointer, we are returning the position of the next empty slot. But at the same time, we are also returning the size of the nums array, the newly found nums array, that is. So in a way it works out. So that will lead us to our solution. So now we're going to try and run this. Okay, so it got accepted. Now we're going to try and submit. Okay, so that was my approach to the solution. Initially, I had thought of creating a new vector, but that would consume extra space because we're creating a new vector, and the in place condition asked from us basically to modify num's array as and when we traverse through it. So this was my approach. Let me know in the comment section if you have a better approach for this. Thank you so much. That's it for today. We will be solving the next question in the next video. Please leave your feedbacks in the comment section and do let me know which problem would you like to discuss next.